So we're continuing on the lesson from yesterday about rational exponents, and you have your papers in front of you so that you can fill in the parts that are necessary to help us. When you have an exponent, our exponent rules apply even when they're fractions. So since our exponent rules apply even when they're fractions, it means that if I have like bases, I can add exponents. If I have power to a power, you multiply exponents. If you have two things, different bases, but you've got a power, that means that power has to be applied to everything that's multiplied inside. So what you can do is apply those rules to fractions. You just have to remember how to add the fractions. So 7 to the 1/5 times 7 to the 4/5, you would add the exponents, and that would give you 7 to what power? 7 to the first power. Good. This one, 3 to the 1/5 and to the 10th power. Oh, see, what do you do with the exponents? So that gives you 2. So this would be 3 squared. How much is 3 squared, everybody? 9. So this one, the 1/2 gets to go to both. So 4 to the 1/2, 5 to the 1/2. Who knows what 4 to the 1/2 power is? 2. So when all is said and done, 7 to the first power, because 1/5 plus 4/5 is 5/5 or 1. That one's just 7. 1/5 times 10 is 2. 3 squared becomes 9. Can somebody explain, though, this one? What does that 1/2 power mean again from the other day? Square root. Good, because the denominator tells you the index. So this tells us the square root of 4, which is 2. 5, square root of 5, we can't really simplify. You can leave it as a fraction exponent, or you could go ahead and write square root 5 on that. That would be just fine. Okay. So we need to go through and we need to look at other rules as they come. So we have more rules. We have the definition of a negative, which we reviewed a little bit yesterday. So our definition of a negative exponent means that it's 1 over that base to a positive power. When we had same base as a fraction with the different powers, we solved that one by subtracting. And then also, even with just regular whole numbers, a to the m over b to the m is the same as when it's combined like this with an m power. So you can use these techniques to begin to simplify these problems. So let me just quickly bring up the next one and I'll cover them up, but be thinking through for a quick minute what the answers might end up being. So, all right, on the first one, when we start to take a look at it, 9 to the negative 1/2 power, what does that look like? First of all, to get rid of the negative. Yes. Good. 1 over 9 to the 1/2 power. So, Alex, what's that become then? What's 9 to the 1/2 power? Yes, altogether 1/3. Good. Because 9 to the 1/2 power is 3. Good. So here we have 6 to the 5/2, 6 to the 3/2. Who can help us out with that one? 6 to the 2nd power. Thank you very much, C. So how'd you get that, Sierra? 5 minus 3. So it's, you said 5 minus 3. So you said 1? Or wait, did you say 2? You said 2? Okay, 2 over 2. That's what you meant. And that's what I heard in my mind, so that's why I said yes. Good job. So 2 over 2, which is 1, and then that's 6. So good idea. 5 halves minus 3 halves is 2 halves, which is 1. Good job. And so then we have this one, 5/8 to the 1/3 power. So that gets brought into both of them. 5 to the 1/3 over 8 to the 1/3. And how much is that? Yes, go ahead, Mika. Cube root of 5 over 2, or 5 to the 1/3 over 2. Either one would be just as correct. Over 2, because remember our denominator here is our index, so this is really cube root of 8, which is 2. Some things are simplifiable, if I can use that word. Some things can be simplified, some things cannot be. So you can do any of the exponent rules apply, even if the exponents are fractions. So for those of you that are great at fractions, you're like, okay, no big deal. For those of you that fractions may not be your favorite thing in the world, need to practice a little bit more. So we have another one, and we can begin to apply it like this. Since we have different exponents here, the best thing to do is rewrite each one with a fraction and then apply the exponent rules. So just as to get us started on this one, let me just do this. I'm going to put it into since it writes better that way. All right, just to get us started on this one, what is our fraction form of the 4th root of x cubed? Okay, good job, Ebony. It's x to the 3 over 4 power over x to the 2 over 8. Okay, now the good thing is that this 2/8 can be reduced, right? How much is 2/8 reduced? 1/4, which is very convenient because we have a 3/4 and we have a 1/4. And then you can take care of this because you have like bases, and that gives you x to 2 over 4. Good job. As you subtract them, and then reduce it, and that gives us x to the 1/2. Good. So x to the 1/2 power, which is the square root of x. So you could write it as x to the 1/2, or you could write it as square root x. And with where we're going on this one, there it is. I have another one that I want you to go ahead and work on. We want to take a look at the cube root of 3 and the 4th root of 3. And I want you to go ahead and use your fractions, use your exponents. Completely separate problem. I'll give you a minute to work that one through. Don't forget with fractions, you sometimes need common denominators. All right, as you've been working on this, we said that first we need to do 3 to the 1/3 times 3 to the 1/4. Then we need to add our exponents. So when you add exponents, don't forget about like bases. 1/3 plus 1/4 is 4/12 over plus 3/12, which gives you 7/12. And then once you have 7/12, the 12 is the index, and then the 7 is the power. And that's how that works. Yes, question? So 3 to the 7/12 is the same as the 12th root of 3 to the 7th power. Remember, if you wanted to, you could put the 12th root of 3 and then put to the 7th power. It doesn't simplify because you don't have 12 threes, so you can't bring any out. So just you just have to be able to leave it alone once you get it to that point. Okay? Good. Now let's take a look at the next one. 16 to the negative 2.5 power. I'm going to put that up on another screen too so I can do this nicely. Get rid of that. So when we begin to do this problem, we need to make this into a fraction. We want 16. We know it's going to be to a negative power. But what is 2.5 as a fraction? 5/2? Good, because it's really 2 and 5/10 for those that need to see it. 2 1/2, which is 5/2. 5/2. Okay, if I have to use an eraser, it's my encouragement to please use a pencil. So negative 5/2. And then you want to rewrite it. We got to get rid of the negative. So what do we do for that? 1/16 to the 5/2. All right, let's write it with, let's write it in its radical form so we can solve it. What goes where? 16 under here, yep, okay. 16 to the 5th power. Do we want to put the 5th power in here or the 5th power outside? Outside, because why did you say that? Why do you think that'll help you? Yeah, because we're going to be able to bring out, remember our 2 is implied in here. We can take the square root of 16 easily. Taking 16 to the 5th power first would be annoying. So how much is the square root of 16? 4. So it's 4 to the 5th, 1/4 to the 5th. 4 to the 5th, you could do that out by hand, but in the interest of time, 4 to the 5th power. Yeah, so 1/1024. So you do have that as an option to help you to get you to that point, 1/1024, 1/1024. And so you watch out with your negative exponents and move it along from there. Okay. And now I want you to try this one, negative 32 to the 4/5 power. Notice in this case, the exponent is not negative, it's this number that's negative. So for this one, you can really go ahead and put it into its radical form just to start with. And watch out for that. We need to be careful not to let the negative throw you off because we really have no issue of taking an odd power, an odd index, an odd root of a negative number. It's the even ones that give us imaginaries. So we're not too upset about this one. See you all busily working. That's good. So when you do this one, you need to do the fifth root of negative 32 and then take that to the fourth power. Fifth root of negative 32. And keep in mind that negative 32 times negative 2 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 gives you negative 32. So negative 2 is our answer to just the fifth root of negative 32. You can have a negative when you have an odd root. You can have a negative when you have an odd root. But if you try to take an even root of a negative, that's where we run into trouble with the imaginaries. But this one's just fine because it's an odd root. And then we take that to the fourth power. So we multiply that out 4 times, you get 16. Because negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So these are things that you can do nicely, hopefully, with these things. So we put them in and do that. All right, let's look at another one. We're going to look at 9 to the negative 3.5. That is very similar to the other one that you did. Same type of a deal. Okay, I'm just going to run through this kind of quickly. How much is negative 3.5 as a fraction? Turn it into a fraction, so negative 3 1/2, right? So what would it be? 7 over 2. So negative 7 over 2. So we can do that. Or 7 over 2 if you bring it over first. You can bring it down first and then make it into the fraction, or you can make it into the fraction first, either one. So 1 over 9 to the 7/2. So we're going to be taking, what's our root? Is it going to be the 7th root, or is it going to be the root of with a 2? 2, which would be a square root, right? Square root of 9 to the 7th power, which gives you 1 over 3 to the 7th, which, once again, if we take the short road out and we go 3 to the 7th power, 2187. So you can take as long or as short of these as you want. Looking back, and you'll be able to take your time going back and re-looking at these notes if need be. We still have plenty of time, but just so that we can get these 16 to the 3/4 power. I know a lot of them are repetitive, but that's just simply so that you can have a whole bunch of them to take a look at. So what is our index for this one, and which is our power? 4 is the index and 3 is the power. So 4 is the index. So 4th root of 16 to the 3rd power. 4th root of 16 to the 3rd power. So what number times itself, times itself, times itself gives us 16? 2. And 2 to the 3rd power is 8. Beautiful. So once you get the hang of these fractions, they really are kind of nice. There's not really that much, hopefully, that's too scary about them. And then we want to take a look at things that get a little bit more difficult, but you're just trying to get yourself so that you're very, very familiar with what's happening with these fractional exponents. So you've got a next one, pardon me while I cover it real quick. Okay, there we go. So we have this one combines a whole bunch of things with it, because we've got this exponent that needs to be applied to everything, but we also have this square root that if we're going to make it nice, we might want to make it into fractions so that you can more easily handle this fraction out the other side. So let's run through this. What I've done first is I've taken this 2/3 and applied it to everything. So you've got -8 to the 2/3, x to the 2/3, and xy square root to the 2/3 power. Okay, so on here, does anybody know how much the square root, the -8 to the 2/3 power would be? Okay, cube root of, good, the cube root of -8 squared. And so that would give you, anybody know the answer to that part? -2 squared, which will be 4, so good. We'll have that when we get to it, but just trying to get you to think a little bit. This is staying the same. And I went ahead and I changed my square root into halves. Remember, our understood 2 is hiding here. So since you've got the understood 2, it's x to the 1/2, y to the 1/2. So you're continually reducing this one. The cube root of -8 is -2. This one we're leaving alone for a minute, but we've got to bring in the 2/3 into those two. So here it is. So our -2 here, because the cube root of -8 is -2. 2/3 times 1/2 is 1/3. 2/3 times 1/2 is 1/3. And we'd already kind of mentally done that this part turns into a 4 by the end. But what other simplifying has to be done here with the variables? Good. Add the exponents with x. So what does that give you? Beautiful. Good. Thanks, Sierra. X to the first power. And y to the 1/3 can be left alone or made into its radical form. X to the 2/3 plus 1/3 is 1. Our -2 got squared. And our x to the 3rd is done. And we have just one more. Okay? You guys are doing great. And hopefully the fraction exponents are not scary anymore. One more. Actually, you've got that one in front of you. I want you to give that one a shot. I'll put this on pause for a minute so you can have a chance to think. All right, so right here, don't forget to distribute this, not distribute, but take this -1/3 and apply it to everything inside the parentheses, 8 to the -1/3. Remember, you're multiplying of 15 times -1/3 is really just 15/3, which is 5. So x to the -5. Then don't forget what to do with your negative exponents. Negative exponents can be turned positive by putting them in the denominator. Then you know the cube root of 8. Because of this exponent that's a fraction, this one's not, so that makes it nice. And 2 times 2 times 2 is 8, so you're left with just this very nice one to end on. So when you start off and you begin seeing them and you begin seeing the fractions, don't worry about them, you know what to do. So great job today, guys. And have a really good weekend. And we won't have class again until Wednesday because of Terra Nova's on Monday and Tuesday. So please make sure you do the assignments that go. We will take questions before you start your work together quiz on Wednesday because Monday and Tuesday are Terra Nova's SU.